In this short video, we will see how the ISE and PPOA model-based systems engineering methodology guides us in the construction of the functional flows of the system from the n-square chart. We recall that to build the functional architecture of the system, this methodology recommends to follow three steps that would be executed iteratively. And the first step, which we explained in a previous video, the functional hierarchy is built and represented with a block definition diagram in SysML. In the second step, an n-square chart is constructed where the functions are their functional interfaces are represented. That is, the exchanges of matter, energy, or data. And the third step, which is what we are going to explain in this video, we build the functional flows using activity diagrams in SysML and using the n-square chart as information on functional dependencies, as well as using engineering criteria that we will see in the next slide. The first considerations that appear in the slide concern how to position functions in the n-square chart. Those functions that only receive input from outside the functional group are placed in the upper left corner, and those functions that only produce outputs outside the functional group are placed in the lower right corner of the n-square chart. The advantage is that when using instance tables in Cameo, the modeling tool, these function movements in the n-square chart are easy to perform. Other considerations are specific to engineering and involve how to handle and model physical processes and processes related to data and signals, which are different even though they might interact with each other through the use of sensors and actuators. In the following slides, Alfonso will apply these considerations to the example of a wind turbine.
Coming back to the wind turbine example, and as it is proposed in the ISE&PPOA methodology, we're going to use the n-squared chart to identify the functional flows, and then we will represent them in one SysML activity diagram. Even though there can be interactions, that is, exchange of items between the functions of those functional flows, which appear in the activity diagram, the ICE&PPOA methodology recommends to represent only the control flows as a first approximation, no? And not showing those object flows between the functions, since we already have used the n-squared chart to represent this interaction, these interfaces. So if we want to identify the functional flows in our system, then we will turn to the n-squared chart that, as you remember, is the map in the ICE&PPOA methodology that tells us how functions connect to each other to exchange items of matter, energy, or data. But before trying to identify any functional flows, the methodology recommends us to reorder the functions of the n-squared chart in a way that those functions that only receive external items are at the left side of the diagonal. Those functions that only produce external items are placed at the right side of the diagonal. And finally, those functions that are involved in feedback loops are as close as possible between them in a way that their inputs and outputs are as close as possible to the diagonal of the chart. Doing this will allow us to see the sequence of transformations to convert external inputs into external outputs, facilitating the identification of the different functional flows of our system. So now that the n-squared chart is sequenced accordingly, that means that we reorder the n-squared chart so that it looks like a sequence of transformations, then we will proceed to identify the functional flows. First, we will tackle the physical flows as it is proposed by the ISE&PPOA methodology. For a wind turbine, the primary physical flow is about the transformation of the wind energy into electrical energy that is provided to the grid. This primary physical flow is, of course, the one related with the main purpose of this system. But there's more. There is also a secondary physical flow working behind the scenes to minimize undesired outputs. This one focuses on reducing vibrations caused by the transformations of the main physical flow. Then, once we have identified the physical flows, we change our focus on the data flows. These are all about information buzzing around to control and monitor the turbine's operations, making sure the system runs correctly and safely. Finally, there is an additional data flow that allows users to interact remotely with the wind turbine to influence the control flow that we just saw in the previous slide. Now that we have identified our functional flows, it is time to represent them. And for doing that, we're going to go directly to the Cameo tool. We already have our model open. The square chart it is displayed here, showing the different functions of our system and their interactions. So the first step is to create our main physical flow. And for doing that, we are going to create a new package containing the, the functional flows. And here we are going to create our activity diagram that is going to collect all the functional flows. So you remember the main physical flow is related to the conversion of the energy that the wind has into the needed high voltage electrical energy. And this involves having function 1, 2, 3, and 4 in place in this flow. No? So we just need to drag and drop the needed functions and reorder them accordingly in the right sequence, the sequence that gives us the exchange of items in this case. There was a secondary physical flow that was running in parallel to the main physical flow that is about to reduce the vibrations produced by the functions of the main physical flow that are related to the conversion of mechanical energy and electricity. No? And it is the one related to function 6. So we look for function 6, drag and drop it on the activity diagram representing the functional flows and put them in parallel. The physical flows are ready, so now we focus on the data flows. Going back to the n-squared chart, remember that we have two data flows running in parallel. The first one is the one related to the control of the main physical flow, that is the one related to F5. So we drag it and drop it. And there was an additional flow related to the communication with external users, that is the one related with function 7. And these two functions are running in parallel. So we just put them and are the functions that will control in the end the behavior of the system. We'll rename the functional flows, rename the diagram, and we have our system functional flows represented accordingly.
To conclude, I recommend you to read our book, Practical Model-Based Systems Engineering, published by Artec House, where the methodology is explained and illustrated with several examples of diverse domains. The methodology website, particularly the resources page and the training offers, is recommended as well. Here you have the QR code of this website. Joining the ISE and PPOA LinkedIn group is a recommendation as well.